Welcome to Part 3 of the Basic Forestry Short Course. This portion is about understanding what you have to work with. My name is Stephen Fitzgerald with the Oregon State University Extension Service, and I will be your instructor. In the previous section, you learned about developing goals and objectives for your property. Developing goals and objectives requires thoughtful consideration of what is really important to you, and although your goals may change over time, they are essential for setting a course for managing your property. Whatever goals and objectives you ultimately decide on, they need to be realistic, that is, achievable. And that's the purpose of this section. By understanding what you have to work with, you will be able to establish achievable goals to guide treatments to maintain or enhance your property. In this section, we'll talk about factors that affect your land's inherent productive capacity, that is, climate, topography, and soils. We will also talk about the current condition and health of your forest, which also influences what is achievable on your property. What would you do if this was your forest? The productive capacity of your property and stand conditions define what I call the ecological sideboards that, as a forest owner, you must operate within to successfully achieve your goals. Every forest property has a unique combination of site and stand conditions. Even within a small parcel, you can have a wide variety of conditions which must be recognized and accounted for when formulating goals and objectives. Forest productivity, or the land's potential to support vegetation, is influenced by three factors: climate, topography, and soils. In the case of trees and forests, site productivity determines what tree species grow there, how big they can grow, and how much wood or biomass your land can support. You can measure or assess productivity for other important aspects of your forest, including wildlife, fish, grass and forage production, and other plants. In fact, the presence of certain understory plant species can be indicators of your land's productivity. Precipitation, in the form of snow and rain, and temperature are two of the most important climatic factors that affect tree and plant growth. Precipitation is particularly important, and this map shows that annual precipitation varies considerably across Oregon. Western Oregon and the higher elevations, such as the Coast and Cascade Ranges, can receive as much as 200 inches per year, while parts of Eastern Oregon receive less than 10 inches per year. In Oregon, we receive very little summertime moisture when plants and trees need it the most. Thus, fall, winter, and spring moisture is absorbed and stored in the soil, providing the reservoir of water needed for tree and plant growth during the summer months. This photo is a good example of the influence of elevation on precipitation levels as expressed by the presence of trees in the upper elevations, where precipitation is higher, compared to the desert region in the distant lowlands. Temperature affects tree and tree growth by regulating photosynthesis, the process by which trees produce their own energy, and ultimately temperature also affects the length of the growing season. Temperatures across Oregon are influenced by elevation, topography, and by the huge thermal mass of the Pacific Ocean, resulting in very moderate temperatures in western Oregon compared to areas further inland. Like precipitation, average temperatures also vary considerably across Oregon. Western Oregon generally has much milder temperatures than Eastern Oregon. The picture on the left shows that in the winter, average temperatures along the coast are relatively warm, get cooler in the Cascades and along the Columbia River, and are coldest in Eastern Oregon. The picture on the right shows that in the summertime, coastal temperatures are cool, but things heat up as you travel east and south. Areas with more moderate temperature regimes have a longer growing season compared to areas with extreme hot or cold periods, which has a strong influence on how much trees can grow within a year. Topography is simply defined as the lay of the land. This includes the elevation, the aspect, the slope or slope steepness, and slope position, such as upper, middle, and lower slope. As elevation increases, temperatures decrease from 3 to 5.5 degrees per 1,000 feet. And as the temperature decreases when you move up in elevation, the growing season becomes shorter, which is reflected in changes in the composition of tree and plant communities. As an example, in eastern Oregon, as you move from the lowest to the highest elevations, the forest composition might change from western juniper to ponderosa pine to mixed pine and fir, and finally to subalpine fir, spruce, and whitebark pine. The direction the slope faces and slope steepness influences the amount of direct sunlight received on the site. What effect would these two contrasting slope directions in this slide have on temperatures, soil moisture, on vegetation, and on site productivity? If you were contemplating planting trees, how would this affect the species you choose for planting? For example, in southwest Oregon, you can have a very productive Douglas fir forest on northerly aspects, and on hotter, more southerly aspects, you might find oak forests primarily. Of course, the soils in these two examples are also different, which we will discuss a little later. Slope position and steepness can have a big influence on soils and temperature, which, in turn, influences the vegetation that can grow there. Here we have a mountain with a primarily east-facing slope. If we were to divide this mountain landscape into upper, middle, and lower slope positions, what might we interpret from this? The upper slope is several thousand feet above the valley floor, so we could expect cooler temperatures and more moisture there. The middle slope is steep, and perhaps some of the soil has eroded to the lower slope position, particularly where trees are absent. In the middle slope position, you can see a difference between south-facing aspects and more northerly aspects, as shown in the small draws where there are trees. The lower slope is less steep and has deeper soils, and is probably very productive compared to the middle slope. Temperatures at the valley floor are warmer compared to the upper slope, which accounts for the ponderosa pine forest found there. Is there anything else we could interpret from this picture? Let's now turn our attention to soils. Soil is very important because soils contain the nutrients and moisture that trees and plants need for growth, and therefore are important for determining the productivity of your forest land. We tend to look at forests from the ground up and overlook soil, but managing your soils for the long term is possibly your most important task as a forest owner. Soils are very slow to develop and nearly impossible to improve, replace, or purchase, but they can be easily damaged or degraded, and forest management practices such as timber harvesting can have effects on your soil. In addition to retaining moisture and nutrients, as noted in the last slide, soils are also home to a wide range of beneficial organisms which break down organic matter and enrich the soil. Also, a tremendous amount of carbon is stored within the soil. But soil is made up of more than just soil particles. Approximately 50% of the soil is actually comprised of pores, where moisture and nutrients are held. These pores also allow for the exchange of oxygen and carbon dioxide in tree roots, which is essential for tree health. Soils often vary, and you may likely encounter a number of soil types across your property, as demonstrated by this typical soil survey map. Each soil type here has its own unique characteristics that affect site productivity. Since each soil type can have a markedly different productive capacity and sensitivity to disturbances from management activities, it's important you know what kind of soils you have to work with. You can obtain information about your soil from local soil surveys. Soil surveys can be obtained from the Natural Resources Conservation Service office in your county or region. Alternatively, soil surveys can now be obtained online at the website shown here. If you go online for soil survey information, here is the page that shows up when you type that address in your web browser. Click on Oregon to access the Oregon soil surveys. Once you've clicked on Oregon, this next page comes up showing all Oregon counties. Click on the county of interest and then click Online Soil Maps to find the soil type of a particular area. It will have a number like 162A. Then click Online Soil Data Reports to find out what kind of descriptions there are for that particular soil. The printed and online soil surveys contain a wealth of information about local climate and growing season, as well as a detailed description of your soil with respect to its timber productivity, susceptibility to compaction, erosion hazard, and other management concerns. Now let's shift our focus and talk about the condition of your forest and how it got that way. We will talk first about forest types, then tree and stand age, forest health, and the history of your forest. In what area of Oregon is your forest property located? Is it in the coastal fog belt forest, in and around the Willamette Valley and Coast Range, in central or eastern Oregon, or even down in southwest Oregon? Each location has a wide variation in precipitation, soils, temperature, which is reflected in the forests that occur there. What kind of forest or stands do you have on your property? Do you have an aspen, ponderosa pine, spruce hemlock, red alder, or Douglas fir forest? You may have a mix of forest types on your property, depending on its location. For example, in western Oregon, you might have both red alder and Douglas fir stands on your property. In eastern Oregon, you could have aspen and ponderosa pine. Each forest type would be managed differently. The plants in the understory of your forest, called indicator plants, can tell you a bit more about your forest and its capabilities. For example, the abundant sword fern in the understory of this Douglas fir stand is an indicator that this is a very productive site. Similarly, other plants can indicate wet or dry conditions. For example, the skunk cabbage plant indicates you may be in a wet area that may pose significant practical and even legal constraints for managing your property. The age of your forest is another important factor to consider. Are your forests young, as shown here on the left, or are they older, like the stand shown on the right? Forests are managed differently given their age and density, which you will learn later in other sections of this program. If you have young forests, you have a greater opportunity to manage and direct their development to meet your objectives. Older forests may provide income opportunities and also provide a more mature habitat for wildlife species. The health of your trees and forest is another very important consideration in determining your goals and objectives. Dealing with health problems or preventing future health problems can drive many of your management decisions. And current health conditions of your forest are often a result of past decisions and events, which we'll talk about a little later. So what do healthy trees look like? Healthy conifer trees have pointy, A-shaped crowns with good crown length, where the crown is about 40% or more of the total height of the tree, and composed of a good complement of dark green needles. Healthy, full crown trees indicate good photosynthetic capacity needed for vigorous tree growth. Healthy trees with a full crown have good diameter growth, although you'll need an increment borer to see this. Finally, healthy trees are free of insects and disease, mistletoe, and other physical damage. Here is a healthy ponderosa pine stand where all the trees display good, healthy crown characteristics. This healthy stand would be resistant to bark beetles and disease. A few unhealthy trees, as shown here by this fading tree in the center of the picture, does not necessarily make the forest unhealthy overall. Dead and dying trees and down logs in a stand can support other ecosystem elements that help provide important ecological functions, such as providing habitat for birds and other wildlife, and nutrient recycling, as trees die, fall to the ground, decay, and enrich the soil. However, if you begin to see more and more trees declining and then die, then your forest may be in a stressed, unhealthy condition. So what are some signs or indicators of poor or declining tree health? Trees that are in declining health can be easy to identify as they exhibit signs such as short or small crowns with few needles. Trees that have a yellowish-green color rather than having dark green foliage often indicate the tree is declining. These trees are easy to pick out next to healthy trees. Also, trees that are in decline may display a decrease in height growth, as shown in this second photo. The two trees on the left show very little current height growth compared to the two trees on the right. Dead or fading tree tops and the presence of a stress cone crop also indicate declining health. Trees that are on the verge of dying often produce cones in a last-ditch effort to reproduce. It's a species survival strategy. Of course, the presence of insects, such as bark beetles shown here, and various kinds of foliage, stem, and root diseases, and mistletoes are indicators of poor health, many of which can spread to other trees. Understanding the type of pest you have is important for determining the type of action that is needed to prevent it from getting worse. Healthy trees and stands can be affected by large weather events such as snow and ice damage, which breaks off the tops of trees as shown here. Wind can snap off or uproot individual trees, and in severe events, affect hundreds and thousands of acres. This is a photo from the December 2007 windstorm that hit the northwest Oregon coast. A large event like this can create habitat for bark beetles to breed and then attack nearby healthy trees. Many of these trees were salvaged by the landowners. Physical damage from logging can stress and sometimes kill individual trees as well. This damage can be minimized by good oversight of the logging operation. Have you ever thought about how your forest came to look the way it does? The history of your forest is important for understanding how it got to where it is and what condition it is in. Essentially, your forest is a reflection of past management decisions and other events. For example, past harvesting activities may have put your forest in a poor condition by removing most of the good trees, as shown here. Or perhaps your forest was managed very well. Each of these stand conditions would require a different management strategy if this was your property. Also, acts of nature like wind, insects, and disease, as previously discussed, can leave a lasting effect on your forest. The bottom line is, you have to manage your forest according to the cards you've been dealt. The condition of your forest will affect your goals and objectives, and drive the management actions you take now and in the future. Let's summarize what's been discussed. The capability of your forest land is a function of climate, topography, and soils. The condition or health of your forest is also a very important consideration. It's important to understand what your forest is capable of so you can establish realistic goals and objectives, and then formulate management actions over time to move your forest in the direction you want. The kind of forest you have and the condition that it's in will influence, in large part, the management actions you take. Looking ahead to Part 4, we will discuss how trees and forests grow over time and how understanding forest development processes can provide insights into managing your property. Thank you again for listening to Part 3, and enjoy the rest of the program.